Morning, ladies and gentlemen. I think we can start. I believe you have already, at least by now, you should have tried question marks, question one, if not until the MTBF, but at least gotten the overall reliability, overall failure rate out. Okay, so let's take a look at these questions. The water flow to the chemical reactor cooling coil is controlled by the system shown in figure 1. The flow is measured by the flow transmitter, the controller and the control valve manipulate the flow of the liquid. I think we have discussed this in the class. Very, very similar. Or in fact, I think it's the same questions. Okay, anyway, we'll do it again. So now we have three. We have the control valve, we have the controller, and also we have the flow meter, the transmitter. Okay, so in that case, that will be the first three if we are to make this a big one. This one for us to see. Okay, so we can see that the controller is 0.29, control valve is 0.6, and flow meter is 1.14. So with that, I believe you have, because we are talking about if one failed, the whole thing will fail. So meaning we will look at the overall reliability first. Yeah, overall reliability. So in the events that if one fail, that everything fails, we will then look at the overall reliability. If we need every components to fail in order to fill the system, then we will look at the overall unreliability as the study. Okay, this is because when we have this overall reliability, is where you basically times all the reliability together. Okay, so with that, we need to study the R1 equals to E negative mu T. So we have controller, leaf that we have studied the other day. So E negative 0.29, that gives you 0.7483. Valves is 0.5488. Transmitter or the flow measurement is 0.3198. Yeah, so this one you have 7483 times 0.5488 times 0.3198. So the overall reliability is really, really low, 1313. It's only 13%. So with that, then we recalculate back the mu equals to E negative T equals to ln 0.1313 negative. Yeah, so you get something like 2.03. So this system failed 2.03 times per year. Okay, so the overall unreliability, if you 1 minus 0.1313, so you get about 86.87%. So the unreliability is for 86 or 87%. So when we want to calculate the overall mean time between failure for this system, it will be 1 over the mean. So 1 over 2.03, we get less than 6 months, 4926. So if you time 12 months, is about 5.9 months. So less than 6 months, the system will already fail. We are expecting the system to fail once. Okay, so this is how we calculate the overall reliability, unreliability, the failure rate, and the mean time between failure. Basically, as I mentioned in the class last week, this is for us to do the estimations or to do planning for scheduled maintenance. Remember before that when we do our HAZOP, we often put in the last column to say, okay, preventive maintenance, regular maintenance needed and all that. So over here, we actually, with the calculations, we would then be able to tell how regular is regular. Like for this case, I would suggest at least once every 5 months, if not once every 4 months to make life easy. So every 4 months, like April you check, and then August you check, and December you check. Like you can schedule it in such a way that you can do it together with the whole system, or also you can plan it together with other system as well to see which one is the lowest MTBF where you can then plan for the maintenance to be scheduled. Okay, any questions so far for this one? This is very straightforward. That's why I do it so fast and just to cover it, so that just to recap your memory. But what I wanted to focus more is on this the event tree and fault tree analysis. Yeah. So let's do this together. Okay, event tree and fault tree analysis, as I mentioned in the class, for the exam purposes, is always question 5. Either question 5 can be either HAZOP analysis or event tree or fault tree. It's either one. You wouldn't get all three. Yeah, so or you wouldn't even get two. It's either one of it. So if let's say event tree is out, then you need to know how to construct the event tree correctly. If it's a HAZOP, you need to remember how to construct it correctly. So for these three methods, right, these three tools, make sure you remember their steps, because all three are very, very different. So let's take a look at these questions. The water storage tank system in figure 2 is the standard storage for water and chemical. Overfilling of storage tank is a common issue in the process industry. To prevent overfilling, the storage tank is equipped with a high-level shutdown system that will shut down the supply to tank. And the high-level shutdown system is connected to a solenoid valve that will stop the flow of input stock. Okay, so that's that. So we have a high-level alarm, and we have a high-level shutdown system. Okay, we have a operator to stop flow in case it doesn't happen. So we also, the high-level switch system, this is the high-level shutdown system, yeah? Okay, so let's construct an inventory. Okay, develop an inventory for the system using the failure of level transmitter as an initiating event. Given that the level indicator fail 5 times a year, estimate the number of overflow expected per year. Use the following data. Okay. This is an interesting one. So when we have a system that fail completely, what are we going to do? Oops. When the transmitter fail, will our system fail? Okay, let's see. So transmitter fail. Okay, so we have the alarm. Okay, high level alarm. So if the alarm fail, operator stop flow. And we have a high level switch system. So meaning when this whole controller is not functioning, but we have an alarm, we have a switch system. So what is our overflow? Meaning this one fail 5 times a year. So when this fail, what happened to our control system? This system failed. Okay, meaning there will not be able to tell us, okay, we have this high level, it cannot control the system. However, since the system mentions that the tank is equipped with a high level shutdown system, means if there's a level somewhere, it will shut down. Okay, it has an alarm as well. So meaning there's a different sensor that is not under the transmitter here. Okay, so with that, let's see. If let's say when we have high level alarm, okay, so 99% of the time the alarm rang, 1% of the time the alarm don't rang. So when the alarm don't rang, what happened? Will the system kick in? I assume the system will kick in, yeah? Okay, so when we have alarm, operator first go in and stop the flow. So how often will operator stop flow? It's written here 20% of the time. That is fail to stop 0.2, but 80% of the time it can stop flow. Okay, so this one is safe. However, with our high alarm system, high level automatic system, so again, if let's say operator didn't manage to stop flow, this one kick in, 99% of the time it will automatic stop flow. 1% of the time it failed to stop. Same thing with 99% is stop flow. Okay, why I'm doing this is that it is obvious that then in that case, the one that doesn't stop flow is only here, it's very low. Because you have operators interfere first, only then you are not able to do it. So what happened is that this is assuming when the system is independent. Means we have an alarm, the alarms will ask the operator to shut down. So at the same time, if the operator fail to shut down, the high level system will continue to shut it down, auto shutdown system. However, in the event, if that we're assuming these two systems are independent, meaning alarm and high level system are independent, means when there's a high level, both will ring at the same time, both will kick in at the same time. But there are also times where people link, when the operators or the engineer link it together. So when you have high level here, okay, when you have a high level here, it rank in such a way that it kickstart it trigger the system to shut down first. If it doesn't shut down, then it goes with alarm. And from alarm, then the operator to shut down. So that you will see that your operations, your event tree will be very different. The event tree will then be this one transmitter field. Okay, so the first one, the first level of defense will be your high level shutdown. Okay, then if high level shutdown fail, only then the alarm will kick in when you have a series. Then with that, only then is your operator to shut down. And then the outcome. Okay, sometimes the outcomes may be different. Sometimes the outcome is still the same. So this one 5 times a year. Okay, this one success 0.99, fail 0.01. So what is success? It is success. So now we have alarm. Okay, so alarm rank 99% of the time. This one 0.01. So this one will fail because operator will not know. Here operator will be notified. So again, 80% of the time manual shutdown, 20 of the time that manual fail. Okay. So as you can see, the failure is different. Okay, so in that case, I think you can do the calculation, but I have a feeling that these two calculations will end up the same. Let's give it a try. So let's see route 1. Okay, so you have this one is the route 1, this one is the route 2. So route 1, we have 0.99 times 0.2 times 0.01 differs. Zero point 0.00198. Route 2, you have 0.01 times 0.01. So total failure 5 times 198 plus 0.0001. So 0.0104 times a year. So mean time between failure is 96.15 years. Okay, let's see this one. Okay, so we have both. I think it's the same answer because looking at this, route 1 is still 0.99 times 0.2 times 0.01, and the route 2 is 0.1 times 0.01. So it will still be the same. So this one will still be the same. There are certain times where when you arrange your sequence differently, or when you arrange the system differently, separate or in series, the outcomes will be very, very different. So in this case, we can see that both outcomes are the same. Yeah, both outcomes, regardless of if you split it, so alarm and the high level switch system run it together, versus you have the shutdown system. First, when shutdown fail, only then alarm rang, it will give you the same MTBF. So it doesn't matter which one, how you arrange it. But in certain example or in certain scenario, where you will notice that to put in different sequences, you will have a different outcome. So in cases like this, then you will have to see which one give you the highest MTBF. So if you have two, when you have two different outcome, okay, choose the route that give highest MTBF. Okay, any questions so far? So this is a simple calculations on to see if how effective is your overflow or of your system. So if you don't have this shutdown system, if you don't have the alarm or high level switch system, or let's say if you don't have your high level switch system, okay, you only have your alarm and operator flow, stop flow, then you will notice that your failure actually will be very, very high, 0.01 plus a 99% plus times 0.2, and with 5 times a year, if let's say we don't have. So case 3 where if high level shutdown is not installed, then what you have is 0.99 plus 0.2, so you will be 5 times 0.99 times 0.2 plus a 0.01. Five times per year, so it will be 1.49 times per year. So the MTBF immediately become 8.05 months. So you can see if case 3, we do not have the high level shutdown system. Okay, your overflow rate for this system will actually drop from 98 years, just 96 years, to once every 8 months. So one sensor or one system actually change the entire system a lot in terms of its failure rate. Okay, do you see the differences? So we know that when you have this high level shutdown system together with your alarm system, with your operator interventions, this system fails once, estimated to fail once every 96 years in terms of probability. However, if let's say you do not have that high level shutdown system, you only solely depends on the alarm and the operators, the system fail once every 8 months. And also from the calculations here, we can see that regardless of how you arrange your alarm or high level switch system, whichever kick in first, the outcome is the same. So you can arrange it in such a way you have the alarm system shut down first, then you have the system shut down first. When it failed to shut down, then the alarm kick in, you will still have the same effect. Okay, any questions so far on this event tree analysis? If no, then let's take a look at the part B. Part B is just now part A talks about inventory analysis. Part B talks about develop a fault tree for the top event storage tank overflow. Use data in table 12.1 to estimate the failure probability of the top event and the expected number of occurrence per year. So what are the most likely failure modes and should the design be improved? So now we talk about storage tank. Oh, 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 as the top event. Okay. So when we look at this storage tank overflow, let's look at the system. Allow me to erase. Apparently, I can erase this. Interesting. Okay, so in that case, allow me to, I can't even expand it. Okay. So what I will do is I'll copy this and I'll paste it here. So that we can really have a good look of this system. Okay. So we know that when the storage tank overflow, there are a few things need to happen. Okay, first is that the level transmitter malfunction. Yep, because we have a level transmitter here, so this one malfunction. Level controller malfunction or level control valve malfunctions, either one of these three, the system fail. It will fail to tell us the actual. So that is the first one, means control system fail. Okay. So, and remember just now we did mention that we have the high level shutdown system as well as the alarm and operator system. So meaning we have the second system here. So that is called, what's it called? The uh, shutdown system or the overflow prevention system. All right. So now we want to determine, do we need one of these to fail for the entire storage tank to go overflow, or either one of these fail, the system will overflow? Is this an AND gate or is this an OR gate? Because remember when we talk about fault tree, we have to decide when it comes to here, is this an AND or OR gate? So here should be AND. Why? Because you need the control system to fail and the overall flow prevention system to fail as well. Only then you get a storage tank overflow. Is that correct? Is that clear? So it will not overflow when these two are intact. Okay, or either one is functioning. Like if the overflow prevention system fail, but your control system is running fine, this system that you're looking at will not fail. But if let's say the control system fail and the overall systems, that the ones that we talk about in this shutdown system, then we have alarm and operator system doesn't fail, your system will not overflow. So again, when we come down to this, we will have three things here. You need to see which one to calculate. Okay, is this an AND gate or is this an OR gate? So for control system to fail, for this system to fail, any one of these fail, the whole system fail. So this one is OR gate here. Okay, so meaning if your level control fail, control valves. First you have the valves, you have the controller, and the last one you have the level transmitter. Okay, so we have this level transmitter, level controller, level control valve. And then we talked about our overflow prevention system. We have what we have here. We have our high level shutdown system, we have our alarm, and we have our operator shutdown. So here we have high level shutdown system, we have our alarm, and we have the operator manual shutdown. Okay, so again here, this is slightly different because you need all of this to fail again in order for the system to fail, correct? Because if let's say your shutdown system is intact, the system will not fail. If the alarm system is intact, your operators manual run it and all that, it will not fail. Only when shutdown system fail, alarm system fail, and operator system fail altogether. In fact, this one, yeah, is where then you will have the system fail. So this one is an AND gate. Any questions so far, class? So this is basically for us to see for the control system to fail, either one failed, the whole system failed. But for the overall overflow prevention system, you need all three to fail, where operator cannot shut down, the alarm fail, and also the high level shutdown to fail. Only then the system will completely fail. Okay, in that case, in fact, I think the alarm and operators are or. The other one is and. Allow me to change the sequence a little bit. So what I would do is I would change this to a two-sided system. So you need this one and this one to fail. Okay, so this one and this one to fail. And this one should be OR gate. The reason is your alarm, when your alarm fail, it will fail. Your operator fail, it will fail too. Okay, alarm plus manual. But this one, if let's say this one fail, will it fail? No, it will goes to this one. You need both alarm and shutdown system to fail. Only then you have the overall fail. But alarm fail, you will have an overall fail. Operators fail, you have an overall fail. So just now we did talk about each of their failure rate here. Yeah, the mu for control valves. Remember from the earlier table, the control valve is 0.6, controller is 0.29. So valve is 0.26, right? Sorry, suddenly I remember. This is 0.29. Oh, say controller first. Yeah, controller is 0.29, valve is 0.6. Sorry, my bad. Point 0.6. Controllers, new controller is 0.29. The level transmitter, remember from question 1, we did mention the level indicator failed 5 times a year. So this guy failed very often. So this one, so the transmitter failed 5 times per year. This is a high level failure. And then we have our shutdown system. It is mentions it failed 0.101, and then it fails 0.2, and but this is by demand, yeah? And it is 0.01. So let's calculate that. So this one is the failure is 0.01. Alarm is also 0.01, but operator's failure is 0.2. Okay, so with that, we need to calculate one by one. What is their failure, overall failure rate? Because we want to know what is the mu t here. Because when we calculate using this one, versus when we calculate using because inventory will only tell you the occurrence of failure if the system fail. But now we are putting into considerations of the overall control system failure and all that to see how often the system break down. That's where we will then take a look at, okay, what do we need to do now? What is the overall failure rate according to the event tree, the for tree. So this one will stop here. So it will be a circle. So this one, if let's say I were to change the name, we call it manual shutdown. Because you use operator and alarm to get the manual shutdown. Okay, so with that, we have this one all gate. So this one is number 1. And so we will have number 2 here. So because we need to do this so that we can get a data here, then we'll have number 3 here. So we'll calculate one by one. Okay, so let's calculate the overall failure rate, control system failure rate. Okay, so we have 3 system here. We have control valve, level control valve. We have level controller. And then we have the level transmitter. Okay, each one has, just to double confirm, if let's say we are referring to the correct. So controller, control valve, it doesn't. So here is level measurements is liquid is 1.7, but since the data, the questions already given us like it is 5 times a year, so we are going to use the 5 times a year. We are not going to use the data here. So depending on what is being given. So over here, I think what we are doing here is correct. The controller we have, control valve we have. Okay. So we are going to use those data. So this one, mu valve is 0.60, mu C is 0.29, and then mu T is 5.0, okay, per year. So let's calculate the overall reliability. Remember, this one is at AND gate. So it means you need one fail to have all of them to fail. So the overall reliability go down. So we calculate by RT for this system, for the control system. Control system is this one. Okay, so we have RV here, like from the earlier data, negative exponential negative 0.60. So it's 0.5488. RC is E negative 0.29. You get 0.7483. So RT here is E negative 5. Okay, let's do the calculation. It's 0.0067338. Okay, so with that, 83 times 0.006738. You get 0.00277. Okay, so mu total CS system is negative ln 0.0277. Yeah. 5.89 watt per year. Okay, so you get this one. The first one out over here is 5.89 for control system. Okay, so now we calculate. Any questions for the first one? Us? Yeah, so the first system we talk about here to calculate what is a control system failure. So now we need to calculate the second one, the manual shutdown. What is the failure rate? So again, here manual shutdown is one fail, either one fail, both fail. Yeah, so means if alarm fail, the operators won't kick in, so it will fail. Operator fail, also it will fail, even though if alarm kick in. So in that case, the second one, failure rate, so alarm is given 0.01. Operator is 0.2. So again, this one is the overall unreliability, because you need both fail in order for it to fail. Shutdown system. So you need RA here, negative 0.01. R naught here is negative 0.2. So let's do the calculation. This one is 0.99. Reliability, this one is 0.82. Okay, so 0.99 times 0.82. You get a very good reliability here. 0.811. Okay, so overall mu TSD is negative ln 0.811. So this is 0.21. So the overall failure rate here, this mu, is 0.21. Okay, class? So this one is shutdown system, manual shutdown system. Any questions so far? So you can see we are actually calculating all these failure rate one by one to calculate the overall failure rate. So we have the manual shutdown calculated from here. One is 99% reliability. and then the other one is 0.2 that the system shutdowns in that sequence. So we get something's about 0.2 because we're about 80% or 79%. And with that, we can calculate. So for system 3, we need a high level shutdown to fail, at the same time the manual shutdown to fail in order for the system to fail. So now with that we can calculate, so let's recalculate back. So number 3 is that the high level overall prevention system. Overflow prevention or shutdown system, depending on what you want to call it, it doesn't matter. So we need both systems to fail. So this one is an AND gate. Oh, sorry, this is an AND gate. Oh dear, I did the wrong calculations, is it? No, correct. So it's an AND gate means you need both to fail in order to fail. In that case, we are going to look at, sorry, this is overall reliability. Overall unreliability, PT, for this shutdown system. Okay, for this system number 3. So means you need P high level shutdown level times P failure rate of this manual shutdown. Okay, so in that case, how do we calculate that? I don't have enough space to do all this. Allow me to add another page then. Okay, now I have extra page. Okay, so just now we already have this reliability of this one. Yeah, so unreliability, okay, I should put this back up here. So the unreliability for manual shutdown systems, we have 1 minus R manual shutdown. Okay, 1 minus 0.811. One minus 0.811. So I get 0.189. So now I also need to calculate what is my overall my reliability for this one, the high level shutdown system. So again, reliability for high level shutdown system is negative 0.99. Sorry, negative 0.01, sorry. So this one just now we calculate is 99%, 0.99. So unreliability is 0.01. So we know our unreliability overall for the shutdown system is 0.189 times 0.01. So you get 0.00189. So your overall reliability, SDS, shutdown system is 1 minus 0.00189 and give you 0.99811. Okay, so your failure rate for this one is long. We'll get something like 0.00190. Am I doing the calculation correctly? Depending on how many zero you put in. So if I would choose, this is 189, 0.00189. Okay, so you have this system. This is a very reliable system. So number 3 here, the mu t is 0.0019. Okay, so you need both to fail in order for your storage tank to fail. Again, so this one is an AND gate, so it will look at the unreliability of the system. Yeah, so again, we will then continue with that. So overall overflow system, tank overflow sequence. So to have overflow, to estimate overflow. So you have both is an AND gate. You look at unreliability. So your P for this first system, PT for control system, P for control system will be 1 minus reliability of your control system. So just now we already calculate the overall control system reliability over here. So it's very low, 0.00277. So 1 minus 0.00277, it gives you 0.99723. Okay, so this is 1. Number 3 here, remember we have number 1 and number 3. So number 3 here, our unreliability, P, the shutdown system that we calculate just now was 0.00189. So So overall unreliability is 0.99723 times 0.00189. So you get something like 0. Just to make sure I did the correct calculations. Yeah. So you get something like 0.00018 also. Let me calculate again if I were to use. Yeah, 0.00188. Oh, 0.01885. Okay, so your reliability overall 1 minus 0.001885 is 0.9981. Okay, so again, your mu total will be negative ln 0.9981. You get 0.00190. Okay, so mean time between failure for this system overall is 1 over mu against with this calculation is 5 to 5.8 years. Am I calculating it correctly? Yes. Okay, so from the 4-tree calculations, you will see that the mean time between failure with your control system intact, with your overall prevention systems, your your failure rate is 0.00190, where your MTBF is 5 to 5.8 years. Okay, the answer is very different from the first calculation because the first calculations only calculate the system failure, sorry. Over here, we only calculate like after it failed. So what is the effects that we work on here? But the 4-tree analysis include the system control system failure as well. Okay. So far, any questions, class? Any questions, class? If no, I think that's about it. So today we cover both all 3 calculations. How do you use the table to calculate the failure rate for your system? And then how do you estimate like what is the failure rate if you're using inventory? But inventory only talks about when your system fails. When one system failed and you have a backup system, that's where then how do you prevent the failure from happen? 4-tree analysis take into considerations of both your control system and your prevention system, your separate overall prevention system to estimate what is your failure rate. Okay, so with that, I think we have covered all of it. I'm not sure if I did any wrong calculations though, because the answers by right shouldn't vary so much. If it's one is 98 and 95 years, the second one's normally is about 100-ish years. I may have made some calculations mistake here and there. So just check. But if not, then I think that's pretty straightforward. Huh? So I have checked all of you have submitted your report for your case study. So please prepare for your presentation. So presentations mainly focus, the rubrics of presentation mainly focus on your presentation skill, your eye contact, your voice and all that. Content-wise is only very, very, very little. So if you want the rubric, I can upload it by today so that you can start preparing your presentations for next week. So tomorrow we are going to have class, lecture class on the topics of a bit of human error, but I'll focus more on code and conducts, like what are the codes, what are the standards that we can use, and then what are the things that we can do for safety. Okay, what are the standards that we follow when it comes to safety measurements and all that. So that is the chapters that without any tutorial, because that is for informations only. It will not come out in exams or anything, but that is a chapter that you would want to refer to when you do your CEGP 1 for next semester. You will do CGP 1 and CGP 2, both you refer to the standards here. So we are going to cover ASTM standard, we are going to talk about UL standard, we are going to talk about British standard, and then we are going to talk about the ISO standard. Okay, so with that, I think then next week, Tuesday, we are going to have that presentations for all of you. And then Thursday, we are going to talk about the case study for BROPA case and also Pepper Alpha. We're going to talk a little bit more about that because even though Tuesday, some of you will be presenting on Piper Alpha, and then Thursday, we're just going to do a recap of the major accidents in the world. Then the following week is a Christmas break, and we come back on week 14. We are going to do revision. With that, we have covered today's chapter is the last for the entire class that will be will be covered in examination. So tomorrow onwards, classes are all for information, but please do come for the class, yeah? So I'll see you all tomorrow, if not next Tuesday, for our presentation. Okay, presentation, everyone must present because individual marks will be given to you for your presentation skill. Any questions so far? If no, then thank you very much. For those who have, because I remember there was one student tell me that he cannot register with the iCheck AICHE. Have you got that sorted out? If no, then you WhatsApp me. Yes or no, you just WhatsApp me and let me know what's the status. Sorted out. Okay, cool. So there are another 4 what's that called? The e-learning courses. Each one will give you 1 point. 1 marks. Do it to get is actually 3 marks for you. So just attend the class and get the certificates and submit the certificates, you'll get the points. Okay, thank you very much. I'll see you tomorrow. Online, yeah?